In logic, proofs are built step by step. But what makes each step valid? Aristotle realized something crucial. The validity of a reasoning step does not depend on the subject matter. It does not matter whether we talk about cars, animals, or imaginary creatures. What matters is the form of the reasoning. These valid reasoning patterns are called rules of inference. A rule of inference has a specific structure. It is made of premises and conclusions. The premises are statements we assume to be true, and the conclusion is the new statement we are allowed to infer given the premises. We usually write these rules in a fraction-like format. The premises go above the line and the conclusion goes below the line. For example, here we have the premises P implies Q and P, and the conclusion Q. This, by the way, shows the rule known as modus ponens. If the premises above the line are true, then the conclusion below the line must also be true. With that structure in mind, let's look at some of the most important rules of reference in predicate logic. But before we do so, let's just remind ourselves that the point here is not memorizing a Latin list. What is important is that you learn how to derive conclusions. So although there are these fancy names like modus ponens, modus tollens, hypothetical syllogism, for computer science, it is not that important that you know these names. With that said, let's go to the rules. First one is modus ponens. What it says is, if P and Q is true and P is true, then you can conclude that Q is also true. For example, if it rains, Bob is king. It rains, therefore we can conclude that Bob is king. Now, I want to call your attention to something important here. As we said before, Aristotle realized that the validity of a reasoning step does not depend on the subject matter. So you may be thinking, what does raining have to do with Bob being a king? Well, the thing is, it doesn't matter. We are talking about the form of the reasoning. That's what a rule of inference is about. We do not care about the subject matter. We care about the form. So this is perfect valid reasoning. Now, modus tollens. What does this rule say? It says that if P implies Q is true and not Q is true, then we can conclude that not P is true. For example, if it rains, Bob is king. Bob is not king, so we can conclude that it did not rain. Next, hypothetical syllogism. If P then Q, and if Q then R, therefore if P then R. Let's go to the example. If it rains, Bob is king. If Bob is king, there will be peace. Therefore, if it rains, there will be peace. Disjunctive syllogism. P or Q and not P, therefore Q. For example, either John brings pizza or pasta. John does not bring pizza. Therefore, John brings pasta. Next, conjunction. If P is true and Q is true, P and Q is true. So it is sunny, it is warm, therefore it is sunny and warm. Simplification. P and Q, therefore P. For example, if it is sunny and warm, then we can conclude that it is sunny. Addition. P is true, therefore P or Q is also true. For example, it is sunny, therefore it is sunny or raining. Next, existential instantiation. If there exists X such that P of X is true, then P of C is true for some particular C. For example, there exists a student who studies logic. So let's call that student Alice, therefore Alice studies logic. Now, universal generalization. If P of C is true for any arbitrary C, then for all X, P of X. For example, suppose C is an arbitrary even number and then C plus 2 is also even. This is our P of C. Therefore, we can generalize it and say that for all X, if X is even, X plus 2 is even. And finally, existential generalization. If P of C is true for some particular C, then there exists X such that P of X. For example, 5 is a prime number Therefore, there exists an x such that x is a prime number.